Alright, hey guys, it's Mr. Palace here, Pendale Science Channel with Lab 23B, Natural Frequency and Resonance. If you recall, frequency is something that occurs with waves, and every wave has a frequency and a wavelength. So we're going to set up our equipment and explore the natural frequency of this string. Alright folks, so to use the equipment, we have some special equipment that we normally don't see. This is called the fiddler head. This will be provided to you. Down here we have the wiggler section. This actually vibrates the string. It's connected by a audio wire to a new box that we haven't used before, and you'll see that there's one connection for that to go in. All right, now we're moving on to part 2, and as you can see, we're discussing the resonance of the vibrating string. So as you change the frequency, we will try to focus in on different harmonics. A harmonic is a specific frequency that reinforces the amplitude of the signal. Here you have the first harmonic, second, all the way across. To get that, we're going to adjust the frequency. I have that turned off right now just so we're not talking over the clicking noise. And one thing to remember that confuses a lot of students is that the wavelength is 2 nodes. So when we're in the first harmonic, then we're going to double that length to get the actual wavelength. So let's set it up, and we'll try and establish some frequencies here and collect some data for part 3. All right, and so now we're ready to collect data for part 3. Reminder, you're in frequency mode, and you need to hold down the button to get into wave mode. Now when you turn it on, it'll select a random frequency, and we want to look for the widest swing of the string, and also when we get to a harmonic frequency, you're going to notice that this clicking gets a little quieter. So I'm going to slowly turn the frequency dial, and you might turn it a little bit and you might not see a response on the screen, so be patient. And I'm just going to go a couple at a time here. And I notice that our wiggler is getting quiet. So I know I'm close, and so now you hear it's louder, so I went too far. All right, so there we go. We have a nice quiet wiggler. The string is swinging out pretty wide, so I'm going to write down this frequency on our data table. So this is 10.3 hertz. All right, next I need to measure the wavelength, and so we have a ruler. And from top to bottom is 1 meter. But if you recall from the top of the page, it takes 2 segments to make a wavelength. So we need to double this, and our wavelength is going to be 2 meters. So that is our first harmonic. Now, while we have this frequency established, we are going to move ahead to the second data table because we're taking measurements for this same harmonic. So in your data table, you have harmonic number 1. The frequency is 10.3 hertz. And now we want to measure amplitude. Amplitude is the deflection of the string. So we can use our smaller ruler here, and we want to go about halfway, always using the metric side, of course, and we recommend that you hold the ruler up against the physics stand. And now you're going to try and eyeball how far the string is vibrating away from the center point. So it looks to be about 5.5 here and 9.8. Let's call it 9.7. So our amplitude was 9.7, and we're going to subtract the 5.5, and that is going to give us 4.2. But if you look at the diagram above, it says amplitude is half of this distance. So take your 4.2 and divide it by 2, and you will get the true amplitude of 2.1 centimeters. All right, now we're ready for our second harmonic. So I am going to slowly twist the dial, and I'm looking for a node to develop right in the middle. And remember, a node is where it looks like the string is not vibrating. You can hear the clicking getting louder. And again, one turn of the dial might not result in a change of frequency, so be patient. All right, I see a nice node developing, and I'm going to look for it, quiet it down a little bit. So there you go. We have a beautiful node developed here. I'm going to measure from the top down to the node. The frequency is 20.6. This is 50 meters, or excuse me, 50 centimeters. So I want to double that to make it 1 meter. All right, now I'm going to go to my second data table and get the width from the widest point. So I'm going to go around here, and it looks like 6.3 and 8.3. So I'm going to subtract those two and divide by half. So this is our second harmonic, 20.6 hertz. And we have an amplitude of 1 centimeter. Right, here we have the fourth harmonic. Our frequency is 40.5. You can see clearly developed nodes and the antinode in the middle. So it takes 2 segments to make 1 wavelength. So if our string is 1 meter, we're just going to divide that by the 4 segments, and we're going to say that our wavelength is 50 centimeters. All right, for our width, this is the amplitude in data table number 2. I am going to try and measure from the widest area, and then I have to divide that by 2. So this is 6.7 and 7.7, so divide that in half, and we have an amplitude of 0.5 centimeters. All right, here is our fifth harmonic. You can see the 5 segments and nodes separating them. So if this string is 1 meter and we have 5 nodes, then that should mean our wavelength should be 40 centimeters. All right, write that into the first data table. For our amplitude, we are in the second data table on the next page. And we need to take the widest spot and then divide it by 2. So we have 6.8 and 7.6. That's 0.8 centimeters. Divide it by 2, and you get an amplitude of 0.4 centimeters. All right, and here we've established the 6th harmonic. And it gets hard to see after a while, but you can see a nice clear node. There should be 5 in the middle and 6 segments. And so our frequency is 59.9. Put that into data table 1. And there is no measurement for the second data table. So this should complete your data collection. All right, our data is collected. So now we want to fill in the rest of table 1. And the last column is frequency times wavelength. So multiply across. 10.3 times 2 is 20.6. Now these units are hertz times meters. If you are in an honor section, you might be asked to simplify these units. Otherwise, just complete the rest of table 1 and you're ready to answer questions. All right, All that's left is for you to complete the questions, and you are finished with Lab 23B.